Good morning, physics students, and welcome to another edition of Physics. It's Mr. Finn coming at you from neighborly Northville. Hey guys, this is the key to all of our circuit troubles. Well, really, not really. This is just a battery. But I need to introduce the battery to kind of close up our discussion on capacitors and get us into some circuit stuff. So, we're going to need to discuss some of the very important pieces of those circuit, the elements of the circuit that make things go, that makes charge move. Now, guys, over the next few days, I'm going to be using some videos that I already made for the other class. Now, I'll be able to piecemeal some other stuff in for you guys because it's a little bit different application. But some of the basic concepts are very much the same. So don't freak out if you view a video and it's referring to a time in the past, because I already made those videos for the other classes who were ahead in this section. So, just for the next week or so, you can ignore any mention of the timing of the Google Forms and the labs. For us, basically, it's going to be labs at the front of the week, maybe a couple of questions on a Google Form in the middle of the week, and then a Google Form quiz at the end of the week. That's pretty much how we're going to roll for the remainder of our time together. So a lab at the beginning of the week, on like usually a FET simulation, a little small Google Form to kind of get you thinking about where you're at, maybe a homework review on the Google Meets, and then a Google Form quiz at the end. So don't worry if you're viewing a video that I made on a Friday and you're viewing on a Wednesday. Don't pay attention to that. I'll have some updates on the Google Classroom to keep you guys updated. Okay guys, let's talk a little bit about what a battery really is, and then we'll do our last thing on capacitors. Okay guys, now let's talk about what a battery really is. Really, we see it as just a small container here with a little knob on the top and really just a flat bottom. But notice the top and the bottom are both metal. That means they're conductive. I have in here a positive ion. It doesn't really matter what the ion is. Something that has a deficit of electrons. Down below, I have a negative ion. Something that has a surplus of electrons. In between is a barrier. These ions cannot move through that barrier. So in order to get these negative electrons back to these positive protons where they want to go, in other words, the excess electrons on the negative ion to the positive ion, we have to allow them to travel through a conductive wire. A conductive wire. So I'm going to introduce that tomorrow in our topic called piece of resistance. We're going to use alligator clips, but you can see wire that's much thicker than this, like if you saw wire in your home or something. Now, to wrap up, we have this parallel plate system. We also know that as a capacitor. So this battery, a voltage source, is going to push charge along. Remember, charge only moves if there's a difference in voltage. Well, obviously there's a difference between the top and the bottom containers or compartments. Electrons are going to move until they bring a surplus of electrons to this plate. At the same time, this plate will be in close proximity to that plate. So electrons, as they are moving this way to this plate to try to spread out, electrons will regress from this plate and move back in towards the battery terminal, leaving a positive charge on this plate. Now, while electrons are flowing, that actually is the flow of charge. Now, when would that flow of charge stop? Let's have a little think about that. When would that flow of charge stop? You might recall that the flow of charge will stop when this is the same strength as that. In other words, when this electric field between these two plates is of the same voltage as this battery setup. when these two plates have the same voltage as the batteries have, there will be no voltage difference. If there's no voltage difference, there is no flow of charge. Now you guys might think, how long will that take? Well, if we don't have any resistance in the circuit, it would happen almost immediately. What I'll try to do is show you, well, I don't have that here, if you could show it on the FET simulation for the lab setup, you can play around with resistors. So let's put one in here. The zigzagged line could be a resistor. It could be a bulb or actually a clay resistor, anything you want. But that resistor will slow the flow of charge. So this plate won't become negatively charged to this value for a little bit of time. If this were a bulb, then while this plate was charging, this bulb would be lit up. As soon as this plate became fully charged, this bulb would stop lighting up and go out, because again, this voltage will be the same as that voltage. And of course, you would know something about the electric field at that point, because the electric field has some relation to voltage. E times D. So the electric field could be found in this capacitor by knowing just the voltage value. Of course, you also know the relationship of voltage from previous videos of capacitance. A capacitor is just the charge per volt. Remember, that's measured in farads, or microfarads, nanofarads, or picofarads, something very small. Because a coulomb is a large amount of charge. We typically have nanocoulombs or millicoulombs or picocoulombs. And that's basically it, guys. Between these two values, we can determine everything we want to know about this capacitor, knowing that it will charge up when the bulb is lit until it becomes the same voltage as this battery. And after that time, it will go out. Okay, guys, so wrapping up here today, we know that a battery is simply a voltage source. Just two compartments, one with a different kind of an ion that's a positive value, and one that has an excess of electrons and it's a negative value. We also know that electrons, eventually with conductive power, like a wire of some kind, can connect and send the electrons back to the positive. But that's not the way that we actually think of the flow of charge. We actually think of that in terms of current. And I'll address that in a little bit later video. But for now, guys, remember this week you're viewing some videos that were made a while ago. So don't freak out if they start talking about dates and times that are not consistent with where we are. We're going to do a lab at the beginning of the week. We have our small Google form just on questions and practice. You guys also have your homework questions in the Google Meets. And then we have the large Google form at the end of the week. And pretty much that's how we're going for the rest of the time. All right, guys, that should about do it for now. I'll try to touch base with you a little bit each day here while you're viewing those older videos, okay? Take it easy and we'll see you tomorrow.